Hello students, welcome to mathematics class. So what we have did in our previous class, as we are discussing about the real numbers chapter 1. So what we did in our previous class, we have solved the problems based upon LCM and HCF, and also we have known the difference between LCM, least common multiple, and highest common factors, isn't it? So we have discussed the difference between multiple and factor, isn't it? Now we have solved by using prime factorization method. I have told you about the method through which we are finding the LCM and HCF. Such method is called as prime factorization method. Before this prime factorization method, we have discussed about Euclid's division algorithm, that is division algorithm method. It means that we can find the LCM and HCF by using algorithm method, and similarly by using prime factorization method also we can find LCM and HCF of two numbers, isn't it? And we have also discussed about the critical problems. Same problem can be converted into jumbled way, okay, puzzled way. If I how that problems are based upon the formula which we have discussed in that class, isn't it? That is A into B is equals to LCM into HCF, isn't it? So we have also solved two questions based upon this formula, isn't it? Formula. Okay, he will be giving three questions, that is he will be giving two numbers and one LCM, he will be asking HCF. Either he will be giving LCM and HCF and one number, you have to find third number. So we have also did an example based upon that. Okay, so before that, in the same class we have also discussed about the problems, the numbers which are ending with the digit 0, isn't it? In try this we will be having same type of problem. Let me discuss you once so that you can be recapturing it in this class. Okay, you are having try this in your textbook. In that we have question as show that okay, 3 power n into 4 power m cannot end with the digit 0 with digit 0 or 5 for any natural numbers n and m, for any natural number n and m. So same topic which we have discussed at the time of 4 power n, 3 power n, 6 power n, 7 power n, okay, 8 power n, what we have discussed. Okay, that same topic we have to remember here and we have to do this in the same way. So what is the solution? Can anyone tell me the solution, how we have solved that? So given form of number is 3 power n into 4 power m, 3 power n into 4 power m. So what do we know, whether when the number is ending with the digit 0 and 5, what do we know? We know that the prime factor, in the prime factorization of such number we will be getting 2 and as well as 5. In what? 2 and 5 in the prime as a prime factors of that number, isn't it? Prime factors of that number. So they will be ending with the digit 0. If the number is ending with the digit 0, then we will be getting, okay, then we will be getting any 5 in that sequence, isn't it? So that we have to write here. We know when number ends with digit 0 and 5, okay, 0 and 5, then it should be divisible by both 5 and 2 for 0 and 5 for the number which ends with the digit 5, isn't it? Okay, this is for first case, that is 5 and 0. For 0 we have 5 and 2, and for 5 it should be divisible by 5. Okay, now as if we take 3 power n and 4 power, it means prime factorization of number should consist 5 and 2 for 0 and 5 for 5. Okay, now so since 3 power n into 4 power n can be written as 3 power n into 2 into 2 whole power m, isn't it? 2 into 2 whole power m. It means this number is divisible. This number is divisible by only 2. Is it divisible by 5? No. So therefore, so since 3 power n into 4 power m, okay, consist 2 in prime factorization but not 5. It may, that is I dot e represent that is 3 power n into 4 power m is divisible by 2 but not 5. It is divisible only by 2. Is it divisible by 5? No, it is not divisible by 5. So therefore it does not ends with the digit 0 or 5. So this is how you have to write the answer. Okay, so hope you all understood this problem based upon the concept of 2 into 5 prime factorization. Okay, so now we will be starting the exercise. In that exercise I will be doing 2 sums so that you can understand it clearly, and remaining you just try. Okay, so we are starting exercise 1.2. In that exercise 1.2, first one, I am just reading the question, okay, and I will directly write the number. So the place is not sufficient to me. Because of that reason I am directly reading the question and I will be writing the number on the board. Okay, express each of the following numbers as product of its prime factor. So here he had given some numbers. For that we have to find the prime factors, and we have to write based upon the fundamental theorem of arithmetic, that is product of primes. Okay, so the numbers are given number in first bit. This is first one. Okay, so 140. For this what we need to do, we need to express as product of primes. Okay, product of primes we need to express. And one more problem I will be doing, that is third one I will do. Third one number is 3825. This one I will be doing later after completion of this. Okay, now coming to the point, you can see here 140 we have to find, we have to write, we have to express in product of primes. For that we have to use prime factorization method, isn't it? So 140 we'll be starting from 2 table. So 2 7s are 14, 2 zeros are 0. Again 2 3s are 6. I'll be getting 1 as here. So 2 5s are 10. So 3 plus 5 I am getting 8. So 8 is not divisible by 3. So directly I will be taking 5. So I will be getting this in 5. 5 7s are 35. 7 1s are 7. So therefore 140 is equals to 2 into 2 into 5 into 7. So this one we have written in a form of product of primes. So what is the product of primes form of 140? 2 into 2 into 5 into 7. This is how we have converted it. We have converted 140 in a form of product of primes. So what do we call this? We call this as fundamental theorem of arithmetic. Okay, so hope you have all understood. Okay, I am doing one more problem. What he had given, question number 3, 3825, isn't it? So for this also I have to write I have to express in a form of product of primes. For that I have to solve it by prime factorization method. So as it is ending with the digit 5, so it will be divisible by 5. It is not divisible by 2. I have to check first 3. So for 3 we have to add this 8 plus 2 10, 10 plus 5 15, 15 plus 3 18. So 18 is divisible by 3. So because of this reason this whole number can be divisible by 3. So in 3 table 3 1s are 3, 3 2s are 6, 7, 8, 2 is remained. So it will become 22. So 3 7s are I will take 21, 1 will be remained, 3 5s are 15 I have got. Again I have to check whether this is divisible by 3 or not. 2 plus 1 3, 3 plus 7 10, 10 plus 5 15, as 15 sum of these digits is divisible by 3, we are getting 15. So let me write here 1 plus 2 plus 7 plus 5. If I add all the digits I am getting 15. So we can divide this sum. 15s are 5, 3 5s are 15. So as the sum is divisible by 3, it means this number is also divisible by 3. So let me check that. 3 4s are 12. 7 I won't get. Before 7 I will be getting 6. So 3 2s are 6. 1 is remained here. Again 3 5s are 15. So again I have to check whether it is divisible by 3 or not. So 5 plus 4 9 10 11. 11 is not divisible, so it is not divisible by 3. Now it is divisible by 5 as it is ending with the digit 5. So 5 8s are 40. Here I will be having 2. So 5 5s are 25. Again I will be getting in 5 table. 5 1s are 5, 6 7 8. Here 3 is remained. 5 7s are 35. Here I will be getting 17. 1s are 17. So therefore product of primes of 3825 are 3 into 3 into 5 into 5 into 17. Okay, so these are the product of primes. So this is how you can solve the question. Okay, so I am erasing this and I am starting second bit. Okay. In second bit, same what we have did in our previous class, he had given that, okay. But here in question you can see exercise 1.2 second bit, first, second, third questions consist of 3 numbers, okay, and fourth and fifth question consist of 2 numbers. So based upon the question, based upon 2 numbers question we have already did. So here we are having 3. No need to scare, okay. Don't be scared. If we are getting 3 numbers, if he is giving 3 numbers, same procedure we have to follow. Okay, let me tell you once. So what he had given in second question, you can see in second question second bit, first one he had given the numbers as 12, 15 and 21. Three numbers, he had given three numbers, and what he asked, find the LCM and HCF of the integers by using prime factorization method. So for this we have to use prime factorization method and we have to find the LCM and HCF. So in examples we have found the LCM and HCF of two numbers, isn't it? But here he had given three numbers. Don't be scared. If he had given three numbers, we'll be using same procedure. Okay, so what we need to do, first he had given, we'll write this as given, these are our integers. What we need to do, we need to find LCM and HCF. We need to find LCM and HCF by what? By using prime factorization method. So here I am using prime factorization method. In that prime factorization method, what we will do, we will be finding the prime factors separately. First I have to find for 12. 2 6 are 12, isn't it? 2 3s are 6, 3 1s are 3. These are the prime factors of 12. Similarly, I have to find 15. 3 5s are 15, 5 1s are 5, isn't it? Hope you all well known about how we are finding the prime factors, okay, as if we have did in example, isn't it? Now coming to 21, I am finding the prime factors of 21. Free table, 3 7s are 21, 7 1s are 7. So this is how we will find the prime factors by using prime factorization method. Okay, now what I will do for comparing, I will write in sequence. So 12 is equals to, 15 is equals to, and 21 equals to. For HCF and LCM, I have to compare all the factors and multiples, isn't it? So for 12, I have got the prime factors as 2 into 3. Similarly, for 15, I have got prime factors as 3 into 5. And similarly, I can write the product of primes of 21 as 3 into 7. Isn't it? The product of primes of 12 are 2 into 3. Product of primes of 15 are 3, 5. Product of primes of 21 are 3 and 7. So for that, we need to find least common multiple, highest common factor. So first finding HCF of 12, 15, 21. So what is that? Common factor. So we have to check which one is the common factor here. 2, no. 3 is common factor in all the three. Here the common factor should be present in all the three numbers. Okay, all the three common prime factors of the three numbers. Okay, so common is only 3. So here we will take only 3 as common. So HCF is directly 3. So the common factor of 12, 15, 21 is 3, highest common factor. Now coming to LCM, least common multiple of 12, 15, 21 is first this common factor we have to write one time, and what we have left with other numbers, that number should be multiplied separately. So what are the left numbers? 2 into 5 into 7. So 2 into 5 into 7. The common terms is taken one time and remaining we have to multiply separately. So now 3 2s are 6, 2 5s are 10 into 7. If I multiply this both, 6 tens are 60 into 7. If I multiply these both, 7 zeros are 0, 7 6 are 7 5s are 35, 7 6 are 42. So 420. So this is the LCM, isn't it? LCM. Therefore, the HCF of 12, 15, 21 is 3. 3 is the highest common factor of all the three numbers. And what about least common multiple? 420. If I take the multiples of 12, then the least commonly multiplied number is 420. Here 420 is the multiple of all the three numbers. Okay, so this is how you will find the LCM and HCF of all the three numbers which he had given. No need to be scared. What you know about two numbers, same steps you have to follow for the three numbers. Okay, hope you all understood. Okay, so second bit, we have did examples. So based upon that examples, you just try once. So now I am going to start third bit. Third bit is also same. We have already discussed what he said in third bit. Check whether 6 power n can end with the digit 0 for any natural number n or not. He had given the number as 6 power n. So we have already discussed, is it end with the digit 0? No, it does not. Why? It is only divisible by, it can be written as 2 into 3. It is only divisible by 2, but not 5. It is not divisible by 5, isn't it? So because of that reason, no. We have did 3 to 4 examples in that, isn't it? You just try. If you have doubts, you can comment me so that we will rectify your doubts. Okay. Now, so third one, you just try. We have already did examples on that. Now coming to question number 4, fourth solution. Okay, fourth solution. What he had asked in the question, he asked that explain why numbers given 7 into 11 into 13 plus 13 and second number is 7 into 6 into 5 into 4 into 3 into 2 into 1 in 1 plus 5. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite. So you can see here, can I say these numbers as a product of primes? No, absolutely I can't. Why? Here I can say product of primes, but plus 13 is adding. Here it is added. Up to here I can say this is prime. This is the product of prime. But this thing, okay, plus 13 is being added to this product of primes. So directly I can't say. Up to here also you can see, if you remove this plus 5, then you will be getting 7 into 6 into 5 into 4 into 3 into 2 into 1. Can I say this as product of primes? No, I can't. This is a product, but it is not about a prime. So why? Because 6 is not a prime number. Again it will be coming in 2 table and 3 table. 4, it is not a prime number. Again it will be coming in 2 table. 2 into 2. Isn't it? So because of that reason I can't say this as a product of primes. So overall thing, he had already said in the question, why? It means that if I ask you, why? It means it is not a doubtful. Why you tear that book? It means there is not a doubt. Okay, isn't it? If I ask you, why you have removed that bag or something else, why you broken that bottle, isn't it? Why you have broken that bottle? Why you have broken that television, if I ask you? Okay, that means that I have seen you. There is no doubt. isn't it? If I ask who, may I know who, or do you, it is question mark. Do you did this, like that, it will be question mark. But here there is no question mark. You can see I have dictated the question. What I have said you the question, why you call these numbers as composite numbers. Why we call, why we are calling this as composite number? Why? He asked why we are calling these composite numbers. It means that he had already solved that and he got these as composite numbers, but he wants us to say that why these are composite numbers. How you can say? Directly you will be adding, they will multiplying this. Okay, maximum people, so what they will do? They will add this 7 into 11, 77 into 13 plus 13. Here you have to use board mass direct. You can't take addition. Multiplication, subtract, like that. MAS, DMAS, board mass, BODMAS. Division, after that multiplication, after that addition, and after that subtraction. So first we have to remove multiplication symbols. After that we have to go to then 77 into 13. If you multiply, 7 3s are 21, 21, 22, 23. Here 1 7s are 7, 7, 1, 10. Again I will be getting 10. That is 1001 plus 13. If I add 13 here, I will be getting, so 1014. If I am taking the prime factors of this 1014, I am getting or not? It is 2 5s are 10, 0, 2 7s are 14. You can't take directly 14, you have to keep 0 here, isn't it? Again it is coming. Okay, 3 table, 3 1s are 3, 3 6s are, 3 9s are 27. Again I will be getting 13 13s are, again I will be getting 13 1s are. So this is the elaborated way, elaboration way. Here what we are doing, elaborating, we are just, what we are doing, we are just doing like a 6th class, 7th class people. We are just multiplying, adding, and after that we are finding the prime factors, and we are checking. Here we are getting prime factors, product of prime factors. Okay, product of prime factors. Again you will be getting composite number. Okay, we can directly, okay, on doing doing the solution, I have got 1014, and after finding the prime factors I got 4 prime factors here. Because of this reason this is composite. Okay, this is the 8th class, 6th class way of doing or solving this problem. Now how you can solve this in easiest way? Okay, you have to solve this in easiest form based upon 10th class way. Okay, so 7 into 11 into 13 plus 13, isn't it? What do we know about the composite number? Composite numbers are the numbers which are having more than 2 factors, isn't it? More than 2 factors. Okay, for that, see here, as we are having plus symbol here, I can take 13 common. Here I have taken 13 common. So if I take 13 common, I will be getting 7 into 11 into 1 plus here 13. I have already taken 13 common here, so I will be getting 1 here, isn't it? If I multiply this 13 into 7 levels are 77, ones are 77 plus 1, isn't it? So 13 into 77 plus 1, I will be getting 78. Here only you have got 2 prime factors, isn't it? This is not prime factor, this is composite. Again, if you want to divide this in prime factors, you can divide this. But what I am going to say here is, here we have got 2 numbers, isn't it? Product of 2 numbers. It is this number, on solving this number, it is getting in 13 table and also it is getting in 78 table, isn't it? So behalf of getting that own table, it is getting in 78 and 13 table, it means that it is composite or not. Okay, so this, like this, will be telling whether the number is composite or, okay, composite or prime number. Okay, so in such way you have to do. So in our next class we will be discussing same 2 problems which are based upon this thing. Okay, so thank you.